With so many choices in visualization design, including use of visual channels, graphical perception allows us to understand how people perceive visualizations such that they properly represent their data. While work has been done in graphical perception in 2D, little is understood about how we should design visualizations for AR and VR displays. With this work, we run an empirical study to compare different visual channels in AR, VR, and desktop displays. In our study, we showed participants visualizations of temperature values as stimuli, with X, Y, and a third dimension, in this case encoded with color, or with a Z dimension and temperature encoded with color. Other stimuli use size or orientation for temperature. Bar chart visualizations use X, Z, and a third height dimension for temperature, and depth visualizations encode temperature along the Z axis. For AR, VR, and desktop displays, we blocked study sessions by task. Extrema tasks required participants to identify the highest or lowest individual point. Quadrant means required that they identify an area, and trend tasks asked participants for an overall trend in the data. For each of the 8 visualizations, one task asked for the largest value, highest average, or increasing trend, and another task asked for the lowest value, lowest average, or decreasing trend. With display type distributed between participants and all other conditions within participants, each participant saw a total of 48 trials. Before each task, participants see the visual channel and dimensionality, as well as whether they're looking for the highest or lowest value. Participants then have the opportunity to navigate to different points of view around the visualization, which in the desktop condition is with a mouse and keyboard interface. For the Extrema task, selecting a data point loads a menu that allows participants to confirm that that is the point that they intended to select. If not, the participant can continue navigating. Once confirmed, the next set of conditions appears and the next visualization loads. Quadrant means tasks are similar, but selecting a point isolates a quadrant or octant with a prompt to confirm. Finally, trend tasks require users to select one of 8 possible trend directions for 3D visualizations, or 6 possible directions for 4D visualizations. The augmented reality interface allows participants to walk around the room to navigate the visualization, which renders in the physical space. A gaze cursor allows participants to hover on data points and menu options, and the trigger on the remote confirms selection as a click. The VR condition provides the same interface as in AR, except data points load against a mid-gray backdrop rather than against the backdrop of the room. We found that participants struggled with 4D size visualizations on the desktop, that performance with color visualizations was worse in AR than for other displays, and that 3D visualizations requiring navigation saw fairly accurate response on the desktop, but were significantly slower. For full results and more detail, please see our paper.